Okay, so this is question 9 from practice paper A. I would do this in component form. I'll show you how to do it by setting up a diagram and using trig later, but using component form, I think it's easier. So we want to know the velocity of the boat. Now, the velocity of the boat is going in this direction on an angle of 245 degrees. If the pen decides to work, that would be great. So it's going round in an angle of 245. So we know that the angle here is 25. So that's the important bit there. 25, that's it. So I know that the velocity of the boat will be negative 18 cos 25 I minus 18 sine 25. So on my calculator you can see that's the first thing that I've put in there. And I've got the numbers negative 17, negative 16, negative 7. It's negative because it's going to the left and down, obviously. I know that the wind velocity apparent to the boat is 28 from the west, so that's just 28I and 0J because it's going directly to the west. Knowing that WVB is equal to VW minus VB, that's a formula that you should know. That becomes that the velocity of the wind will be the relative velocity plus the velocity of the boat, just by rearranging that formula. So I can get the velocity of the wind, that's my second line in here. The 28.0 plus the negative 18 cos 25 minus the 18 sine 25. That comes out to be 11.697.61. Okay. If the velocity of the boat is reversed and the magnitude, the speed is changed to be 20, it will become 20 cos 25 positive because it's going in the opposite direction, and 20 sine 25. So that's my new. I'll just write it as a column vector. Let's make sure that we know that this is the new velocity of the boat. Therefore, the relative velocity of the boat, of the wind to the boat, going back to that formula, will be VW minus the velocity of the boat. That's the formula from before. The velocity of the wind we've already worked out. That's the 11.697.61. And we need to subtract the velocity of the boat. That's 20 cos 25, 20 sine 25. Okay, that comes out when we pop it into your calculator. You can see this line here that I've popped it in, and that gives me out the vector 9.87 negative 8.45. At this stage you need to change it back to have a magnitude and a direction. You can do that on your calculator just by pressing 2 polar. So changing it to polar says that the magnitude is going to be 17.3 kilometers per hour. Obviously you could do that just by going 9.87 squared plus negative 8.45 squared and square rooting it, okay? And the angle is negative 111. So if we want that as a bearing, all we've got to do is add on this bit here, which is obviously 90. So the bearing of the direction of this apparent wind is 90 plus 111 is 202 degrees. And that is the final answer.